What if I told you an animal softer than jelly is secretly protecting entire coastlines from destruction? Every ecosystem in the world relies on a foundational rule. To support life, you need vast expanses of fertile ground. On land, dense rainforests grow out of thousands of miles of rich soil. But out in the open ocean, the water is a barren, nutrient-poor blue desert where life should struggle to survive. Yet in these aquatic wastelands, a tiny, fragile organism builds structures so massive they can be seen from space, single-handedly supporting a quarter of all marine life on Earth. Welcome to Wonderdocs Studio. Today we reveal why these fragile stone structures hold the fate of our entire planet. This is the miracle of the coral reef. Occupying less than 0.2% of the ocean floor, these structures form a thin ribbon along 150,000 kilometers of coastline across 100 countries. If you look at a healthy reef from above, it looks like a bustling, hyper-dense metropolis in the middle of an empty ocean. Over 4,000 species of fish pack into these limestone sanctuaries. It is a biological paradox, a geographic microscopic dot that generates $36 billion in annual global income while anchoring the survival of the entire marine food chain. They don't just live in the ocean, they physically build it from scratch. Because the open ocean lacks nutrients, corals must perform a feat of hyper-efficient biology. A coral polyp is actually an animal living in a perfect, symbiotic relationship with a microscopic alga called zooxanthellae. The algae live inside the coral's tissues, using sunlight to perform photosynthesis and sharing up to 90% of the energy they create directly with the host. In return, the coral animal uses that energy to extract calcium and carbonate ions from the seawater, cementing them together to form a hard exoskeleton of solid limestone. We call this calcification. To support the ocean, the coral acts as a biological architect. Over thousands of years, trillions of these tiny, millimeter-wide skeletons stack up to create complex three-dimensional labyrinths filled with infinite caves and grooves. But their architecture extends far beyond the water. The reef acts as a massive organic net that alters the geology of the planet. When grazing creatures like the parrotfish scrape algae off the reef, they grind up the inedible calcium carbonate skeletons in their guts, excreting hundreds of pounds of pure white sand every single year. Driven by ocean currents, this coral sand aggregates to form shallow banks, entirely new islands, and eventually the foundations for coastal mangrove forests. The reef doesn't just create land, it protects it. Acting as a natural self-healing breakwater, a coral reef is 97% effective at absorbing the raw thermodynamic energy of waves, mitigating the destructive forces of cyclones, hurricanes, and tsunamis before they hit human settlements. Humanity spends billions of dollars mimicking this process, pouring heavy concrete blocks into fragile coastlines, constructing artificial barriers, and running expensive coastal defense initiatives. We use massive machinery and industrial resources to protect our cities from rising tides. The coral does it effortlessly. No concrete mixers, no engineering blueprints, just a tiny animal pulling minerals from the water to build a shield that keeps entire atoll nations from vanishing into the sea. Yet the magic of the reef is hidden inside its chemical code. Beyond food and shelter, these organisms produce unique biochemical compounds to survive the harsh marine environment. Scientists are now discovering that these exact compounds hold the keys to advanced medicine, yielding breakthrough antibiotics that target drug-resistant bacteria alongside treatments for cancer and viruses. Scientists first fully calculated the global scale of this reliance only recently. For decades, we viewed reefs as isolated tropical tourist attractions. It took advanced structural mapping to realize that if these tiny limestone structures bleach and collapse due to rising sea temperatures, a catastrophic domino effect triggers worldwide. Fisheries instantly collapse, coastal protection disappears, and a multi-billion-dollar economy evaporates. Every human engineering project assumes we must build on a massive scale to have a massive impact. Theirs alters the fate of an entire planet from the microscopic level up, anchoring the global ocean inside a shell thinner than a fingernail. Somewhere in the shallows right now, trillions of microscopic architects are silently cementing the future of our blue planet together, one stone at a time.